Hello and welcome into the new episode of How It's Built. Today we're joined by Bridger Maxwell, who in his spare time built a really impressive tool for collaborative drawing called Scribble Together. We're going to talk about some aspects of software architecture as well as some unique challenges that come both with real-time and the drawing aspects of this app. Hope you enjoy it. Thanks so much for taking the time. This is Bridger Maxwell, who is working on Facebook on the product called Origami. In his spare time, Bridger, you built this pretty impressive app called Scribble Together. And in this time when everyone is working remotely, this is 2020 and coronavirus pandemic, lockdown, and all that became part of our daily vocabulary. This app seems really useful. Can you talk a bit more about why did you decide to build it, and how did you see the usage of the app working out in the recent time?
Yeah, so this is an app that Mei Ku and I have been working on for I think over 3 years now. And it started out with Mei trying to work with remote designers on her team. And I was working with my niece trying to tutor from New York to Utah. And I found that most of the whiteboards were too complicated to work with like kids. You know, we'd get stuck just trying to figure out email links and passwords and sign up. And then in the whiteboard, we'd get lost. And so we were trying to make an app that lets you have the experience of sharing a piece of paper or a whiteboard in person, where it's less about like how many bells and whistles it has, and more making sure that it doesn't get in the way of drawing and expressing yourself in a way that's visual. Because I think a lot of ideas are really hard to express without visual aid. During when everyone was switching to working from home, we saw a lot more downloads. We're also trying to promote that we don't want it priced to be like a barrier to people who need to use this for education or any other reason. So we also have a code if you want, where you can enter 4 soap emojis into the join board, and it'll give you some months free. There are some schools that have group subscriptions. And so we can do it where anyone with the school email address, if they put it into the app and confirm their email, it'll do the subscription that way. We've
Nice.
had a few teachers that have really championed the app within their district or community of teachers.
There are not that many apps in the App Store where the core feature is multi-user, right? So I feel like that's a pretty interesting kind of part of the architecture that maybe we can start discussing. So maybe you can talk a bit about that.
The core part of it is that people can draw in real time, and you want to be able to see the changes really quickly. Anytime that there's syncing involved between people, the thing that you want to deal with is conflicts are going to be the hardest of. There's always a time delay with networking. And even if there wasn't a time delay, we allow people to draw on the whiteboard when they're offline. And so multiple people might do that, and then they all connect and the changes go up to the server. And we want to make sure that everyone ends up looking at the same whiteboard once all the conflicts are resolved. Which in whiteboarding is not that hard of a problem. There's only, most of the time people are just adding on, but you want to make sure like things end up in the right order. So if I draw a big blue square and you draw a yellow triangle at the same location, we both think that we drew it first. But when it comes to both of our whiteboards, we need to make sure that it looks the same, that it's either the yellow triangle is on top for both of us or the other way around. But as long as it looks the same is what we're going for in Scribble. Mm-hmm. And so a lot of the syncing is done by sending deltas of like what has changed. So there are messages that will say, insert a stroke here and then add points to this stroke, or hide this stroke if you use the bomb eraser on it, mm-hmm. or add a canvas. The way I organize it locally is that we have the canvas client. We call it, or I called it client canvas. when I started making this instead of whiteboard. And even though that doesn't show up anywhere in the product, it's stuck. The Canvas client will have messages for mutations. So this is where you say like add stroke, or append points, or hide stroke. Generates a log of messages. So it's like 1, add stroke, 2, append, 3, append, you know, someone's drawing for a while.
And so this is purely local. This is just purely based on what I'm as a user kind of performing as an action, right?
Yes. And then these need to be applied locally. So then the Canvas client also keeps a track of like its current state of the world, which is the model of, I don't know, should I draw as like a really big thing? So this is the Canvas model. And it has within it, in Scribble, you can have multiple sheets. Like each one is kind of a whole window that swaps out. And so within the Canvas model is an array of canvases. And each one of those has a bunch of strokes.
Do you ever end up optimizing some strokes? So for example, if I drew 5 strokes in a row, do you ever end up like merging them? Because I know that some like algorithms that kind of, I think that's Google Wave, if anyone remembers that, they used to have this thing where they would zip a bunch of operations. So that's like if you add, delete, they kind of zip it into no operation at all, because that's what it amounts to. Do you do any of that with the model?
There's some cases where I can throw away data that I know is no longer needed. Like we have disappearing strokes where you draw and it shows up live and then they fade away. When we save the model to disk, we don't save those because we know that they'll never show again. But once they're drawn, each stroke is independent. And you can always unhide a stroke. And so even if something's hidden from the bomb eraser, there's a chance that someone will undo. But the models have generally been not that big. You know, like syncing that has been not as much the bottleneck. One of the tricky parts is that these are like local messages. I call them canvas to server messages. And they get transformed into messages that actually mutate the model in a way that makes sure that even if they get out of order, you end up with the same whiteboard. We also have the Canvas server. This is usually running remotely, but I have it all as like a model object, so I can run unit tests locally where I say, here's 5 clients and they all connect to the same server. And instead of using WebSockets to pass messages, we just use some like local testing mocks to pass them around.
Nice, you have tests. That's great.
Well, I have the ability to write tests. I've written like 4.
Okay. Ability to write tests is the next best thing.
Yeah. So the Canvas server has multiple messages coming in from different clients, and it needs to relay them to the other ones. So they come back. So the Canvas client sends these to the server, and then the server is going to transform them and send them out to all the other clients. And the Canvas server...
Just to clarify here something, so Canvas server is the actual server. So this is not a P2P application. This is an application where you actually have a server running somewhere on something like Amazon or you know, alike. And so that's the source of truth. Okay.
Yeah. This is not peer-to-peer. one of the trade-offs with peer-to-peer is that you can't really have a web app that shows you the whiteboard at any time if it's peer-to-peer, because by having it stored on the server, that means you can go to scribbletogether.com/boards and see the list of your boards and open it up. If that was peer-to-peer, that would have to somehow like phone your iPad, which might be in your backpack, and like try to get the data. So the source of truth in the end lives on the server when it's being synced.
Okay. Can you talk a bit about logic that, so you mentioned that server is the one that's responsible for resolving all the conflicts. So what is the, like, and you mentioned that in your case, conflict resolution is potentially a bit simpler than it would be like in text, word processing or something like that. So what is your kind of take on that? What kind of algorithms did you use for that?
Yeah, so one of the simplest is that when you say add stroke on the client, it always just assumes, okay, it's going in at the end. And the server is the one who transforms it. It looks at what strokes are already in the model. And it says, we're adding it after yellow triangle. And so it transforms it to a message that is not just like append, but it's saying insert it exactly here. If you hear about something late and you've already drawn, the server can send it to you and say, you didn't know about this, but it happened 5 minutes ago. And so it should go like got it here in your model.
So all those appends and then strokes, they have some data about the actual drawing, but also they have data about timestamp when this actually happened, right?
The server assigns them like an authoritative, like this is the order that it happened.
Got it. Okay.
Yeah.
Cool.
And so they come out here as mutating messages. Only those are sent to the clients, and these like have definite order, or they're phrased in such a way that even if things happened out of order, when you apply these, they will all end up looking the same.
Got it.
But one of the things that's tricky is that it goes to the server and it gets transformed and then sent out to all of these clients. But as you're drawing locally, you want to see it immediately. You don't want to wait for it to come back to the server.
Right.
There's the same algorithm running to optimistically apply them on the client, and run that same algorithm's running on the server and then going to all the other clients. In order to transform from canvas to server messages to mutating messages, you need a snapshot of the current model, which is something of a weakness in our architecture, in that it does make that the server is very stateful. I'm not sure if I could have gotten around that, but I'll put like a copy here of the canvas model on the canvas server. The code on the client and the server is so similar that I opted to go with Swift on the server for this part. And that has turned out pretty nice.
Okay.
Like you don't have to write it twice, and like the core algorithm can be unit tested because it's all in the same language, even though I said that I didn't test all that much.
No, can be unit tested. That's the important part.
Yeah. And so
how was it to write Swift on the server? Because I remember that, early on people would say, I'm not even sure if up to this day there are any sort of, kind of industrial scale sort of applications running in Swift. What was your experience like?
At first it was pretty rough. Like even connecting to Postgres database might be like something kind of tricky and flaky without the right, like there wasn't battle tested libraries for it. Vapor has kind of come out as a really more battle tested, or like it's just a kind of one out and has some really nice APIs. And so I actually rewrote from Katura to Vapor, which took a little while. And I've also found that a lot of things I wanted to specialize a little more with the Swift. So the Swift code was good at running this this syncing logic, but there's a lot of other things the server does about just like registering for accounts and like serving web pages, things like that. I decided the infra wasn't mature enough there to rely on all that and have that part in Python. And so I'm using like Flask Python for a lot of the things that most web apps would do.
Yeah. Like more of a lightweight, just kind of showing the web content stuff.
Yeah. And I'm using the Swift server in a way that's a little closer to how I develop iOS apps, in that like it is a stateful server and is more like a running app rather than like request response quite as much.
Got it. So does this mean that like as soon as I start a session, me as a user, you get a instance of a server standing up just for me, just for my particular client, and then like everyone who connects to my canvas, to my whiteboard, they talk to the same server?
It's important that everyone who is connected to the same whiteboard connects to the same server. Each server can still serve many clients at once, or like many whiteboards. And so right now I only have one server, and that's just like been fine. But scaling it will mean that we have multiple servers and each one can serve, I don't know, like 3,000 whiteboards or something. But everyone who's on the same whiteboard will need to be connected to the same server.
Got it.
But it has made it very fast. I am curious to hear how other real-time syncing things kind of deal with that. Like, for example, a VoIP call might be a similar thing where I think everyone needs to connect to the same server for it to like take a group call, composite it into images that it's sending.
Well, that's actually an interesting question, because what I would guess is that if you have like some sort of really mature VoIP infrastructure and you're serving, let's say you connect call between America, Asia, and Africa, I'm guessing that you would probably want to have servers in respective regions, and then somehow maybe you would be able to duplicate this among all the servers in real time so that you can get like faster speed. But yeah, I guess this is just me speculating. I'm not even sure if that's how it works.
Yeah, I'm not sure.
Okay, and so I wanted to kind of get back to the part where you mentioned the Canvas client, right? And so what is the kind of networking, like bare bones networking? So you have a server, and it sounds like you mentioned it's not like your typical like request response style communication. So what is your client kind of networking stack?
It uses WebSockets, and it's not the Canvas client or the Canvas server that directly networks. And so this is actually one that I need to refactor a little bit, but the thing that drives the Canvas client is our Canvas view controller. So I would like, yeah, it's a big one. I actually don't mind big view controllers as long as every part of it is pretty understandable. I don't care about number methods as much.
What was the biggest view controller in Origami?
Oh, those get so big. we actually did a code analysis. There's something that kind of gives a score of like how complicated is code, and Origami ranked just below. I think it was the most complicated code except for React Native, maybe.
Oh my god!
In like that,
and React Native has a lot of like stuff built there over time.
I'm afraid that I misquoted that, though. I hope I didn't get that wrong, but it was right up there in some of the most complicated code that Facebook's got in the FB-obc repo. The Canvas view controller is what's telling the Canvas client what to do, and so it's also the thing that networks or keeps open the WebSocket. And so I'd like to factor out the part about the WebSocket in particular. The Canvas view controller connects with the WebSocket to the actual server, or Canvas client has a callback where it can say like new messages, or so you say like trigger actions from the view, like drawing. And so Canvas view controller kind of asks the Canvas client to do that. We have a view that manages which sheets are available. You can give it the Canvas client directly and say like, anytime that you want to add a sheet or whatever, anybody can use Canvas client to mutate the model and like ask it to create things.
Got
But
it.
then, and then anybody can subscribe to changes from the Canvas model.
Mm-hmm.
So Canvas model changed. These come back from the Canvas client to whatever views are subscribing. And a lot of those views are owned by Canvas View Controller. So views. And then there's another delegate method from Canvas client to Canvas View Controller, which is just a one way,
mm-hmm.
which just says like, I have messages to send to server. And so the Canvas client says, I have a bunch of messages queued up, ready to send. The Canvas View Controller asks for them, stuffs them in the WebSocket, and then when things come back from the network, this is also asking the Canvas client, apply these messages.
Mm-hmm.
And then those in turn will change the Canvas model, which triggers those Canvas model has changed across all the different views. So each view can subscribe to the Canvas client itself, so it knows about state changes across the app.
Got it.
But the thing coordinating between the Canvas client and the network happens to be Canvas View Controller. One of the things that side effect is that whiteboards only sync when you have them like open visibly. And so I would refactor this to say like, here is a Canvas syncing controller or something that knows how to open up a WebSocket and does this top part about
mm-hmm.
Messages to send to the server and applying messages from the server. And I could abstract that. So it's just a thing that knows how to connect a WebSocket and like pass messages for it. And I would do that if we ever had like background syncing where we detect that you went from nowhere network to network and you have written on 5 different whiteboards. So we'll sync those.
Mm-hmm.
But that hasn't been important yet because most people are using this real time, like on a phone call. So a lot of syncing apps are about like, you know, I'm writing notes while I'm on the subway. And then when I get to my Mac, I just expect the notes to be there.
Mm-hmm.
And that's kind of like a personal notebook syncing. This one is a real-time communication syncing. And it's not asynchronous as often, where you like do something and then you expect it to end up there sometime later.
Yeah, that's a pretty good point, though. I think that's like it's a good point about kind of trade-offs, just understanding what is your core use case and not building, you know, something that's not necessarily required at the moment. And yeah, like once you kind of want to support background syncing, or if you want this code to live, I don't know, in the world where you receive a notification that someone started drawing on your whiteboard and you want to show that Canvas and notification quickly respond with something like that, that modularity might be interesting. But yeah, until then it seems pretty. And so far I have to say the Canvas view control sounds like a reasonable view control. It only receives messages from the views, forwards them to someone, receives messages back, forwards to someone else. So it's like, it's pretty good.
Yeah, it's trying to just be an in-between. It doesn't have very much logic about. Yeah, the logic within it is mostly just passing things, trying to get it to the right place.
Yeah.
So it's more like a router in that way.
Yeah, that makes sense. How many, like, speaking of view controllers, it seems like you have, again, like, you know, when you look at any given app without knowing it too well, it always seems like, oh, it's so simple, like there are only 2 views, but then like,
screens.
Yeah, I'm curious how many different view controls are in your app, and through that, how complicated the navigation system is, and if you ever have to go from one view control to another.
Navigation is actually as simple as it looks on this one. So we have the home view controller and the canvas view controller just push within, you know, within a navigation stack. We do support multiple windows, and that means, and now the app clip. it means that you can have a window that is just the canvas view controller and you can't go back to a home view controller because there is no home view controller in the app clip. And so that's supported too, but I don't have like a very elegant way of doing that. I find NS user activity is an odd API in that they're like, here's 5 user activities. Each one has a little bit of info and like try to reconstruct your view hierarchy from that. And I'm like, which one should I use? Should I use the state restoration or should I use the one with the web activity or what's this app clip payload? I don't, so far I haven't needed to use that. That's weird.
Yeah, I think at some point, I might be, again, kind of misquoting that, but at some point, I think I heard that someone said like, oh, it might be that API was built for one purpose and then other teams starting kind of piling up their things on this user activity, and it kind of grew to be this
half-typed dictionary of just like, here's a bunch of info where, you know, we have specific API names, so it's not just in NS dictionary, but it does come down to it will return you some strings and you got to do something with those strings.
You said that you have support to several windows. Can you have the same canvas open from multiple windows?
No, I had to enforce that at like the app level of making sure that that didn't happen.
Switching gears a bit, I noticed that you have this cool feature that allows you to recognize different shapes when you draw. So you can kind of draw a rough version of a circle, and it actually makes it a nice looking version of a circle. So can you talk a bit more about that? How did you approach that?
Yeah, so that the shape recognition is driven by a few different like recognizers, where the first point in the shape recognition is that we try to pick out corners. And so like notice when there's a change in direction, which is not as simple as it sounds. It's really easy to like think something in the middle of a line is a corner, or near the end of the line, it gets kind of messy. And like there's 4 points that could be considered the corner in this like messy corner. Which one is it? And so that was kind of a specialized subsystem of just like, here are all the corners that are possible, and like trying to weed out ones where first it looks at the individual level to find all the corners and then kind of looks macroscopic and is like, that can't be a corner because it's in the middle of a line. Even though there was like a kink in the line. And then that gets passed to a few different shape recognizers that try to say like, okay, if I assume that this is a quadrilateral, there must be 4 corners. The shape or the corner recognizer gave me like 6 possible corners. So I'm going to one by one drop each corner and say like, well, what if it's these? What if it's these? What if it... same with like triangle.
So you're going to score all the possible outcomes, and based on that, you say like, oh, this scored the highest as a square or as a circle, and therefore...
Right. And then we score it based on like, okay, if you assume that it was drawn perfectly, how far... And then you kind of just like, how far away are the points that were drawn from your perfect version of the shape, and kind of sum that up and score it.
Okay.
And then that lets us kind of compare across different shapes, where you're like, this recognizer tried a square, this one tried a rectangle, this one tried a triangle, which one's fitting the best. And then most of those are just kind of a geometry based. I spent a lot of time just reading those geometry sites about like a parallelogram will have bisectors that are exactly crossing in the middle of each other. And I'm like, okay, so that makes me I can look at the corners and say, well, this bisector is too long, so I can move the corner this way, and that will make it a trapezoid instead of a less perfect shape. Most of those are just kind of like heuristics from geometry that I try. But then the circle and oval recognizer is instead a linear regression model where we just try to fit the equation of an ellipse to it. And it runs, that uses ellipse detector. Hold on. Uses the accelerate framework as a linear regression function.
Oh, so you wrote it from scratch. You didn't use any sort of it's called CoreML or anything like that, right?
No. I mean, Accelerate is similar, I guess, to CoreML. Or, you know, like I didn't write the solver, this like the linear algebra sort of algorithm from scratch. But most of I didn't pull in any other big libraries.
Okay.
And this was also this is the one part that I did rely on something from recent-ish, iOS 11. And so now the shape recognition requires iOS 11, but the rest of the app works on back to iOS 9. If you still got an iPad too. Those things are sold for years and years.
Oh yeah, yeah. It was a nightmare for everyone who was like, I don't want to support this, but I have to. How many different shapes do you support there?
So there's lines, quadrilaterals, like four-sided shapes, triangles, and then ellipses. And then each one of those tries to like also have a more perfect version. So like the triangle runs, and if it fits a triangle, then it's like, what if we adjusted one of the corners so that it is a isosceles triangle?
Right.
And like it's allowed to move. I just have some fudge factors where I'm like, an isosceles triangle is 0.87% better than a regular triangle. And so we're allowed to like be off by that much if we can make it isosceles.
Okay.
And so within so then we do isosceles and equilateral triangles. And then within four-sided shapes, we support like parallelograms, trapezoids, rectangles, and squares are all things that it recognizes as like better than most four-sided shapes. iOS 14 added a feature for shape recognition, and they also named it Scribble.
No.
Yeah. We had it first, and so I don't think they could kick us off. I'm less interested in trying to make trouble for Apple legally.
Right.
And we also try to use the name Scribble Together as like a full name more often.
Yeah, that makes sense.
And Scribble doesn't show up in the iOS 14 UI. Like Apple's feature is not really named exactly. It's more marketing named only.
Oh, got it. Okay.
So, hopefully it doesn't confuse people.
It is always perceived as a small, nice to have feature. But then once you actually talk through how much it takes to build it.
Yeah, and one of the tricky things with just drawing in this way, where we have, you know, messages we're sending to the server and also shape recognition, is when do you show it to the user locally, and when do you like commit it to the model? Because actually, one interesting way that we process strokes or like drawing is that we need to simplify the lines. Apple Pencil, actually, if you take every single point from the Apple Pencil and just render it directly, it looks okay, but it's also a really big data model.
Yeah.
But when you're drawing with a finger, if you just take every single point and display it directly, it looks bad.
Yeah.
And so we have a series of like cleanup things that run. Our drawing algorithm first goes through a simplifier. Simplifier is just trying to remove points that aren't visibly needed, as in like they're exactly in between its two neighbor points. Yeah. We do a corner corrector. Can't remember the exact reason for that. Oh, it's because the next thing that we do is we smooth them based on midpoints. Point smoother. And this midpoint smoother would mess up really sharp corners. So this corner corrector kind of pre-processes it so that it doesn't. But those three, it means that like you can't really know what. It's kind of like if you put 30 points into there, it kind of processes them, you know, in a queue where the midpoint smoother can't emit any points until it has 3, and then it can like emit 1. So it delays everything by 2. The corner corrector delays it, the other one delays it. And so that means that by the time that we're getting points out of there, the points that come out of there, we're ready to send to the network. Those are kind of like finalized, but we want to display them locally much sooner than that. We actually also use the Apple Pencil API where it's predicting where the Apple Pencil might be.
Yeah, I was going to say that it sounds similar because it gives you like raw points and then it like comes back and corrects them, right? Something like that.
It actually tries to predict where the pencil is going to be in like 2 frames. And because it's about 2 frames behind, it makes it look like it's exactly on. So yeah, we have that, but we also need to have like this path where we generate like preview points of this half of the line is far enough in the path that it's finalized and we can send it to the network. This half of the line is still kind of being smoothed and corner corrected, and it might be based on predicted points that are not yet ready to like commit to. Yeah. And so that's one place where there's kind of an exception to everyone just listens to Canvas client to hear like when to update their views. There's an exception of like the stroke that you are currently drawing on your local iPad also needs to have some messages coming directly from the drawing gesture recognizer of like, here's a preview. Like, we think this is what it's going to look like. Yeah, the stroke is made of half of committed points, and then the tail end of it is also local changes. And so that's like there's a few places where we wish that everything went through Canvas client and like was neat that way. But there's a few places where we have to kind of fast track it. And shape recognition, I'm planning to change soon to do the similar, where right now when it recognizes the shape, it's done, it's committed. And the tricky point with that is that the gesture for recognizing a shape is that you stop drawing for a moment and you hold. So that means if you draw slowly, I might think that you're done and be like, it's a line, and to like stop you from drawing anymore. And so instead, I want to say, if you stop drawing, we'll try to predict it and we'll show it to you. But then if you keep drawing, we need to like undo it and allow you to keep going.
You rightfully mentioned that like it's not always when you get to build a beautiful architecture and everything works with it, and you already have 2 exceptions from the rule. So do you think that you will have some sort of different approach to how you accumulate messages, or like is there any sort of common theme that you see between the shape recognition and what you described as a second subsystem?
I think the way that I've kind of reconciled these is I always want to make sure that it's separate of like what is the committed data model and what is the stuff that's like locally applied, so that you don't get them mixed up or like merged together in any way. And so like the stroke view that I have, like both points to the data model stroke, and then it has an extra IVAR called like preview points. And when right before we render it, we merge all those together to just be one continuous line. But they're stored separately to make it very clear that like this part always comes from Canvas client, and this part can come from a view, you know, like a more, a different path.
Is it fair to say that it's somewhat similar in the sense to that feature that you described when you do disappearing line? So it's some sort of like only local data that never leaves? Or is it...
The disappearing line, it still goes through the whole process of being committed to a Canvas stroke.
I was kind of curious, you know, from all the kind of, so you mentioned that you have a massive view controller. It doesn't sound too massive yet, but I will take your word for it. Do you have any sort of singletons, any sort of fun stuff like that?
We have singletons for doing like subscription state, you know, like store. Most of the singletons are related to user account sort of stuff. Instead of doing them as singletons, I have one object I call app dependencies that is created pretty early on and then just like passed everywhere. So it's like app dependencies dot subscription client, or app dependencies dot like there's a document database class that is responsible for serializing these documents or unserializing them, or just like displaying, you know, getting a list of all the documents for the home views If I made two document databases, it would probably be bad because they both try to write to the same file. So it should only ever be a singleton, but I don't have a singleton like accessor that will get it out of nowhere.
So sockets, WebSockets, I feel like that's the one that I use them multiple times in like different projects, and it always felt like this kind of flakier sibling of HTTP connection, where you can never know. You can never know if the information actually made it or not. Like what is the story with error handling in your kind of in this app? Like how do you approach that?
First, I want to make sure that like these messages are idempotent. Like the server knows, hey, I've already got these messages from this client up to this point. And so I can throw those away. I've already got them. And then these are the new ones. And so if something happens where like the client accidentally sends things twice, for example, that's okay. And so it might like try to send something and then a little bit later it notices the connection went down. So it reestablishes the connection and the server sends a message that says, I'm confirmed you're connected. Here are some new messages that happened since last time you're connected. And here is the last message that I've heard from you. So the server says like, here's what I know about what you've sent so far. And then that, and then the Canvas view controller goes back to the Canvas client and says, usually I'm sending these in real time, but instead give me everything that happened since Thursday or whatever, because that's the last time that the server acknowledged that it got a message from us. It still relies on it being kind of a queue for a single connection, that like everything that you put in the connection arrives in the right order. And that's nice that WebSockets guarantees that. And WebSockets also nice in that usually it's easier to connect a WebSocket in like more restricted network environments, because it starts out looking like a regular HTTP request,
right? And
then it like kind of just stays open and becomes WebSocket. So it's less likely to be blocked than if you use some other random port or some other different protocol.
Do you remember when the world moved to HTTP2 and that, I think that specification had like kind of way to maintain connection open. So in a way it was kind of like inching into the territory of WebSockets. And I think that became a standard because early on only Google supported it, but then eventually they kind of propagated. It was called SPDY, like SPDDY, something like that. They were cool with names back then. It looks like I use it multiple times and it looks like a pretty solid product, but I'm kind of curious, what is your current focus?
Yeah. One is trying to scale up the web app. I said that we share a lot of code between the clients. Web app, unfortunately, is just JavaScript from scratch. And so JavaScript, we re-implement the Canvas client, things like that. And so we're trying to also get like feature parity there. There's other features that we want to just do some features that we said, this will be a nice problem to have. Like if enough people use it that they're like, oh, I could really use search and folders and stuff like that. That'll be a nice problem to have. And now we have it. People are asking for folders like every day.
Nice. Congrats.
And so some of those niceties within the whiteboard, I'd also really like to do text support so that you can type, especially for people who are using the browser. It's easier to use the keyboard. And then also like inline images. Right now you can add an image and use it as like the background. But we will be adding images that work more like stickers that you can pick up and move. Another thing that's interesting in here is that we use either OpenGL or Metal to render all of these strokes. And I was really surprised how much you get for free from normal like CoreGraphics, like create a filled shape. It took me forever to figure out how to tessellate into triangles using libtests, and like I had no idea how much work displaying a shadow was. Like we have a a tool where we're like, okay, you circle things and it picks up and it'll show a shadow, and like that was a rabbit hole for a while. Learning all that from scratch.
I was gonna ask, if you use any core graphics. So it sounds like none whatsoever, right? Not for the core of the algorithm.
We use CoreGraphics when you export as a PDF to draw there. But the whiteboard is Metal, and it was like drastically faster. So before, the way that we were doing it was actually with CALayers. We had CA shape layers. And a thing that makes ink look a lot better is if the lines can change thickness as you go, depending on like speed that you're drawing at the time. And a regular CoreGraphics path doesn't support that. So the way that we were doing it was that you kind of make a filled shape instead of saying like just line to here. You zoom in on the line and you make it thick.
You outline, kind of line itself, and then fill the insides. Yeah.
Right. And that, I don't know if it was that caused it to be slow, but like it was pretty easy to draw for 10 minutes and end up with a screen that when you tried to zoom was like terribly slow.
Right.
But now rendering it with metal, where we are using the same technique, but now we, break that down into triangles. It's so fast. That's really cool.
Yeah.
But like, I can hardly draw enough
really snappy
to make it slow.
Have you tried to use just CoreGraphics, like as in like you have single view and you just store the commands, like a queue of commands, and you keep redrawing them, or was that slow too?
I tried versus the CALayer or the just calling it, and CALayer was still faster because I think it cached some. And usually, like the thing that changed is you're adding a stroke on top. But now we made this conversion before I added the tool where you could pick things up and move them. So I don't know what performance would have been like in that case. But now that it's in metal, it does just draw every stroke. Like there's no buffers that we're rendering lines to, or no bitmaps that we're rendering to beforehand. It's all immediately rendered every frame.
All right, neat. So I think we can try to wrap it up here. And any sort of where can people find you? What is the best way to get in touch with you if they want to kind of pick your brains or suggest any of their sort of solutions to any sort of problems that you're kind of facing?
Yeah, Twitter's good, at BridgerMax. Or if it's about Scribble, I run our support line. So help@scribbletogether.com.
Nice. Very cool. Okay, sweet. Thanks so much for taking the time to chat about the app and how you build it. It's a pretty unique app in the fact that it has the all this kind of collaborative features, and we don't see that too often in the App Store. Thanks so much.
Great to see you, Sash.